Hello, my name is Talha Kamran, and today I'll present a project, Hybrid Standalone Power System for the community of St. Mary's Harbour. This is situated in Newfoundland, Canada. So all the remote communities around the world need cost-effective solutions and reliable energy systems. But a transmission line network from the grid cannot work and is not feasible because it is very costly and because of the harsh weather conditions. So we need standalone energy systems. For our project, we used Homer Pro to select a suitable hybrid energy system for our site, and then we also did comparison with other energy systems. So this is our system design, which we made on Homer Pro, and the community that we selected was St. Mary's Harbour in Newfoundland, Canada, and the coordinates are given below. So as we can see the schematic, it has a lot of components. So let's see all the components one by one. The first is our electrical load profile. So the daily energy consumption of that area is around 165.44 kilowatt hour per day, and the peak load is 20.46 kilowatt, whereas the average load is 6.89 kilowatt. So the batteries that our system selected and uh, on Homer Pro was PowerSafe SPS 1200 batteries. Their specification is given below. They are around 1400 ampere hour battery, and it costs about $2,500 per battery. It has a lifetime of 15 years. Next up is the diesel generator. So we use the Generac protector generator with a capacity of 20 kilowatt, and it costs around $8,500 with a lifetime of 15,000 hours. So its fuel consumption and efficiency is given in the graphs on the right. So the wind turbine that was selected for this purpose is Bergy XL6. It is a 6 kilowatt wind turbine, and it costs about $30,000 with a lifetime of about 20 years. So the solar panels that we use for this purpose was Fronius Simo flat plate PV system, and they're about 5 kilowatt solar panels, but that's the overall capacity, and it costs about $3,000 per 1 kilowatt of PV panels. It has a good lifespan of about 25 years. So for the system, because it has DC and AC components, so the power converter that we used was Caterpillar uh, BDI SI 1PH converter. It has a specification of 18 kilowatt, and it costs about $18,000 with a lifetime of 20 years. Now, if we see the system resources, so that's these both figures show the actual resource present at St. Mary's Harbour. This was selected through the Homer Pro's profiles. It has stored all the PV resource and the wind resource of different areas. So the average solar radiation is 3.05 kilowatt hour per meter square per day in St. Mary's, and the wind power resource that's about 8.71 meter per second average annual wind speed. So these graphs also show the monthly profiles. As you can see, the solar radiation is higher in the summer months, whereas the wind resource, so the wind speed is higher in the winter months.
Hello, I'm Siddhant Kotian and I will be taking over the presentation from here. First, let's talk about the energy analysis. There are multiple components generating electricity or power in this main system. The three main ones are the wind turbine, the solar panels, and the diesel generator. Whereas the wind turbine is giving the majority of the powers, such as 77.1% of the annual energy generated is given by the wind turbine, which is 49,881 kilowatt hours. And next, the solar PV panels produce 10.3% of the generated power per year, which would be 6,657.6 kilowatt hours. Whereas the diesel generator produces the second highest, which is the 12.6% of the annual energy and that is 8,149 kilowatt hours, whereas annual energy consumed total is 60,386 kilowatt hours. Now, looking at looking at the Homer simulations, as we have used Homer Proof to simulate this, we can see that majority of the energy is given by the Burji XL6, which was the turbine selected for this, and the renewable factor, which means the total amount of renewable energy used instead of fossil fuels, is 86.5%, and the excess energy per year is kept to 2,516 kilowatt hours per year, which is at a minimum of 3.89%, which has been which is a decent amount. And the total NPC on the total sorry, and the total levelized cost of energy is $0.322. Next, here on the screen right now showed are the conservation of energy equations. These were the equations you used to calculate and assess the amount of energy you used or would be required by the systems. Now, coming to cost analysis. In the cost analysis, we can see the most cost is taken by the generic 20 kilowatt protector. Next is the Burji XL6, that is a wind turbine, whereas the highest capital cost would go to the Burji XL6, which is $60,000. But uh, in the overall cost, the system would cost up to uh, 251,000 for this main system. Talking about this system here, the fuel prices are kept at $1.7 per liter, and the average scale uh, and the sorry, and the average uh, irradiation data is 3.05 kilowatt hours per meter square per day, whereas the average wind speed uh, given to for the energy would be 8.71 meter square per second. These are the main data taken. Uh, these are the main average data taken while assessing all the simulations done by a Homo Pro analysis. And the future slides will be taken over by uh, will be taken over.
Hello, I'm Ananjan De and I'm taking over of the presentation from this slide. In this slide, we can see the proposed system comparison with on-grid electricity. The electrical energy produced by the proposed hybrid system is around 64,687 kilowatt hour per year. Taking into account the present electricity cost for Newfoundland is around $0.13 per kilowatt hour. The estimated payback time between the proposed hybrid system and on-grid electricity can be calculated. Thus, if a proposed system produces the same amount of electrical energy every year and avoids the on-grid electricity, then this project will save around $8,709.3 amount per year, and it will get its money back in 28.26 years. It is a great standalone hybrid project with excellent figures as it requires low maintenance over the years and supplies reliable electrical energy. On the next slide, we have discussed about the sensitivity analysis. On the left, I have put the serial number, and on the middle is the sensitivity variables examined in Homer simulation software. So we have put their wind speed, solar irradiation, electrical load, and diesel fuel price. In this project, four sensitivity variables have been considered, that is diesel fuel price, electrical load, wind speed, and solar irradiation. Homer Pro Optimizer has simulated all the feasible power system combinations and configurations by taking into account all the input values of sensitivity variables. Now, we have calculated the feasible solution and best sensitivity case in the Homer simulation module. The figure shows the calculation report of overall simulations performed by the Homer optimization tool. In total of 89,068 solutions were simulated against a total of 80 sensitivity cases. On the right, we have the calculation report. Over 89,068 solutions were simulated. Only 67,908 were feasible. The rest of 21,160 were infeasible due to the capacity shortage constraint, and 19,608 were omitted due to infeasibility, lacking a converter, having an unnecessary converter, and for no sources of power generation. The most feasible solution, which is the sensitivity case of our interest, having the present local conditions, has NPC of $251,389, an initial capital cost of $131,000 against sensitive values of irradiation. In this project, the proposed hybrid system designed and simulated for the community of St. Mary's Harbour, Canada is an excellent power generation system. This standalone hybrid energy system comprising solar power, wind turbines, and a diesel generator is an excellent substitute for the traditional diesel power plants or coal power plants used before. Also, having battery backup increases the reliability and provides power for a few days when there is lower solar and wind output. Overall, considering all the simulation results with a few modifications depending upon the location, this hybrid energy system can be installed in remote communities everywhere in Newfoundland. Thank you.